Now we're going to cover an experiment summary and all of the different aspects of looking at an experiment for a FASTQ experiment. This is the opener to working with an experiment on Rosalind. And as a FASTQ experiment, which I can see right here, there are a couple things that are unique to this. So one, I'm immediately greeted by some important QC plots over here at the left. I'll be able to look at these more extensively in a moment. I can see the title and description of this experiment. It was sequencing, it was RNA-Seq from FASTQ. Human was aligned with genome build HG19, was using the NEB Next Ultra 2 RNA-Seq library prep kit for Illumina. There are 32 samples, 3 different primary attributes using the NCBI bioproject data model for cell line time course and treatment. There are replicates in this experiment, and the experiment owner is Tim. As I look at this, also I can see the method section that's ready to go. I can just copy and paste this into any work that I may need to do. I have a series of related experiments, and at the moment this experiment is not in the collaborative mode, which I can go ahead and do by selecting to share this into one of my existing collaboration spaces. So let's say I want to put this into my collaboration space, and I'll go ahead and share that experiment in just like that. Now, I could click on any one of these QC plots, but I'm going to do that in a moment, because next I'm going to go to the QC tab. And once I do, we see an important set of information. So for those bioinformaticians in the audience or others that are looking for this information, this is where we can see a lot of the key details. So the Q30 scores, reads that are too short, bases that were number of bases trimmed, the alignment values, and the number of duplicates. Now, if any one of these goes off the rails and deviates from the normal ranges that you should see, Rosalind will throw a bar across the top, add a new column for assessment, and tell you contamination, for example. So we automatically look for and detect contamination. If we find it, we will blast against all known species from NCBI to determine what is contaminating your samples and identify that, or maybe there's too much ribosomal RNA or whatever, we'll flag that for you based on what's there. So it's a great way to get confidence in the strength of our standardized RNA-Seq secondary analysis pipeline. And here we can see very good Q30 scores. Alignment is 85 and above across the board, actually 178 there. So alignment's looking pretty good for these samples. So feeling good about the QC that's here. Next, I can look at the correlation heat map. Everything is downloadable, including a CSV with the key values, a high-res SVG or a PNG for a quick drop into presentations. So the violin plot, looking at the distribution of reads, again, very clean. A quick look at the genomic regions that came back across the 5' and 3' regions. And an MDS plot. So this is our equivalent of doing any kind of PCA. And as we mouse around with these, this is a historical experiment, so it still has the text names. But when this is performed today, there's one overview, and then all of the others include nice little dots that summarize the data for each of the attributes within the experiment. And also we give the coverage plot. And so you can see the distribution of reads from the 5' to the 3' end, and giving a nice view across all samples. So looking very, very clean on this experiment here. We get a listing of sample metadata. Again, this one has replicates, so we can see the replicate groups. So the 3 controls, so DMSO, were grouped. I can scroll and see all that metadata. And if I were the owner of this experiment, I'd be able to add more metadata. This is a demo, so it doesn't let me modify the metadata. Or I can say none and turn off that grouping so we don't get that nice coloring for the replicates. On the download tab, there's several nice values that are here. I have a higher level of access, which is also available for bioinformatic teams. So if you want to be able to see some of the, so for example, BAM files, or some of the QC applications, all of these key resources associated with the experiment are here and ready to go. Also for the bioinformatics folks in the audience, a full summary of all the data associated with each comparison is downloadable, which makes a great way to mine some of the results without having to recreate any comparisons and be able to prepare some bespoke analysis where not using the Rosalind experience. And then beyond that is moving into all of the comparisons and the normalized expression that are available within every experiment in Rosalind. And that summarizes a quick view of the experiment summary for a FASTQ-based experiment within Rosalind on RNA-Seq.